The purpose of this video is to demonstrate the protocol for processing and storing the blood samples that will be shipped to the MACH15 Central Biobank. Before you begin working with the samples, be sure you are wearing the appropriate personal protective equipment. Each MACH15 participant will be submitting a number of samples that will need to be processed by the local clinical labs and then stored and shipped to the Central Biobank. Upon receipt, please be sure that you have received the following Central Biobank samples, including 2 10 milliliter EDTA blood tubes, 1 10 milliliter red top serum blood tube, 1 screw cap urine specimen container, and 1 hair sample, which is optional. You will also have 1 packet of paperwork, which includes a lab collection and processing form, and 1 packet of labels. Included in the label set are duplicate labels that have a colored stripe running through them. These labels are to be used for completing the lab collection and processing form. The other set of plain white labels are to be used for labeling the vials. Before you begin, please make sure that the set IDs on the lab collection and processing form match the set ID on the remaining labels. This step is essential because the set ID is what links the PID to the samples going forward. You will also need to confirm that the form has been filled out appropriately and that you have received all of the samples that were collected. For each sample, be sure to check that both the set ID and the unique ID on the sample matches what is on the form. Before you begin working with the samples, it's important to make sure you've set up a clean workspace with all of your supplies, including bench paper, wet ice, disposable gloves, 2 tube racks, disinfectant spray, disposable pipettes, a metered pipette, a biohazard container, labels, a rack with vials for the EDTA samples, spare gauze pads, tissue paper, a second rack with vials for the serum samples, and wide-bore transfer pipette tips. You will also need extra caps for the 0.5 milliliter vials that do not come pre-capped. In addition, we recommend that you have a centrifuge with aerosol-resistant canisters and a scale that can be used for balancing these canisters. The first step in processing the Central Biobank samples is to make sure that the red top serum blood tube has incubated for 1 hour at room temperature. During this incubation period, be sure to place EDTA blood tubes in a 4 degrees centigrade refrigerator. Please note, you should always label the vials before you centrifuge the samples. In the event that you are missing labels, please use this time to prepare replacement labels. In order to process the samples for the Central Biobank, you will need to have 2 types of vials. One is a 0.5 milliliter vial, which has a tapered inside, and the other, larger, is the 2.0 milliliter vial. In total, you will need 6 of the 0.5 milliliter vials and 4 of the 2.0 milliliter vials. When setting up your racks, please be sure to place your vials in order according to Figure 5 from Chapter 7 of the MACH15 MOC. In order to begin labeling, please locate the white labels. As a reminder, the color striped labels are to be used on the lab collection and processing form. Occasionally, you may find you have a blank label. Please know these are a relic of the printing process and it does not represent a missing label. If you have not already done so, please double check that you have all the required labels. Be sure, as you label, that you are working up from the bottom of the labels. You will begin by labeling the vials for the samples collected from the EDTA tubes, which include plasma, white blood cells, and red blood cells. Take care to apply each label to the correct vial and in the correct order. Next, you will label the serum vials that will be collected from the red top serum blood tube. In the end, you will have the following 10 vials available for all. After incubating the samples, you will need to load the blood tubes into pre-chilled 4-degree aerosol-resistant canisters using a scale as needed to help balance the load evenly around the rotor. The central biobank uses an Eppendorf centrifuge number 5810R. Once loaded and balanced into the pre-chilled centrifuge, you will spin the samples for 20 minutes at 4 degrees Celsius at 1530 Gs or RCS. We are now ready to begin aliquoting the EDTA samples. Be sure you have set up a clean workspace with wet ice and that your samples are sitting in a tube rack above the ice. As you look over the EDTA samples, you will see that the sample has separated into 3 layers: a plasma layer on top, a white blood cell layer in the middle, and the red blood cell layer below. We will be extracting samples from each one of these components. In preparation for aliquoting the 4 plasma samples, uncap the vials, placing each of the caps in a clean, dry place. You should also ensure that the metered pipettes that you will be using are set to the desired volumes. Using a gauze pad so as not to soil your glove, remove the stopper from the EDTA tubes. You will begin by inserting the pipette into the plasma layer and aliquoting the 2 0.3 milliliter plasma vials. In addition, you will use a transfer pipette to aliquot the 2 remaining 1.8 plasma vials. Be careful not to remove all of the plasma, but instead leave a small layer of plasma over the white blood cell layer, holding the tube at eye level as necessary. Be sure to cap the plasma aliquot vials and discard used pipettes into a biohazard container before moving on. We are now ready to begin aliquoting the white blood cell samples. Please note, in order to create the full complement of the white blood cell vials, it may be that we need both EDTA tubes. Therefore, you should not discard samples until all of the aliquots have been collected. Verify that the pipettes are set to the correct volume and insert the tip of the pipette into the thin white blood cell layer. Swirling the tip along the edge of the tube, keep the tip within the 2 to 3 millimeter layer. Carefully take up the 0.5 milliliter volume and release into the 0.5 milliliter aliquot vial. Unlike other vials, the 0.5 milliliter vials have additional space and can accommodate up to the 0.6 milliliters. Therefore, it is fine to add the full 0.5 milliliters. In order to fill the second 0.5 white blood cell vial, repeat these steps using the second EDTA blood tube as needed. Before moving on to the next sample, please be sure to cap all the vials and discard any used pipettes. We are now ready to aliquot the red blood cell vials. Insert the pipette into the middle layer of the red blood cell layer, taking up the 1.8 milliliters of red blood cell and depositing it into the 2 remaining vials. Never fill beyond the 1.8 line on the vial. This helps to prevent cracking upon freezing. As a final step, be sure to cap all of the vials and discard any used pipettes and material into the appropriate biohazard container. Since hemolysis may interfere with assays in the future that are conducted on plasma samples, it is important to assess hemolysis level and determine which plasma samples should be kept or rejected. Please use the standard key for hemolysis from Chapter 7 of the MACH15 map as a guide when assessing hemolysis levels in your plasma. It is important to note that hemolysis should be analyzed only after the sample has been aliquoted out into the vials, as plasma samples often appear darker in the original collection tube. You are now ready to aliquot the two serum samples. Double check that the set ID on the tube matches the IDs on the vials and uncap each of the vials. Again, using a gauze pad, uncap the rubber stopper from the red top serum tube and use a transfer pipette to draw up the 1.8 milliliter volume. Release this volume into the vial, taking care not to go beyond the 1.8 milliliter line. Leave a small layer of serum over the clot. It's important that you do not attempt to draw out all the serum. Repeat these steps and fill the second vial of 1.8 milliliter serum. As a final step, cap all of the vials and dispose of any used materials and pipettes in the biohazard container. Once you have processed the blood samples for a participant, you will need to be sure that you have completed the lab collection processing form. For each of the vials that were created, you will affix the corresponding color stripe labeled to the form and provide detailed information about the aliquot. We will be using this form later to upload information to the MACH15 website. Now ready to box the samples for storage. For more information on labeling the boxes, please see Chapter 7 of the MACH15 MOC. The Central Biobank will provide boxes, grids, and vials with color-coded caps which are pre-labeled with a unique box ID. These are called anchor box and should be placed in the first spot of the box, top left corner, prior to placing any samples in the box. You will begin filling the box using the EDTA samples we collected, starting with the 0.3 milliliter vials of plasma and then proceeding through the remaining samples. For reference, please see Appendix D, which demonstrates the correct order for storing each of the samples. It's important to freeze the samples immediately at -80°C. If specimens cannot be frozen immediately, the boxes may be stored for no more than 2 hours at -20°C or on dry ice until transferred to -80°C or below. Be sure to record the box and vial location in the freezer inventory log for each sample, and to note the freezing time on the lab collection and processing form. As a reminder, all freezers should be equipped with emergency backup power, and check daily to ensure that they are keeping their temperature accurately. Please reference Chapter 7 of the MACH15 MOC for more information on freezer best practices. The final step for processing Central Biobank samples is to enter your records into the MACH15 website. You'll need to enter information from the lab collection and processing form and update the freezer inventory log page on the MACH15 website. For the full set of instructions related to processing Central Biobank samples, please see the MACH15 MOC Chapter 7. If you have questions related to this video, please contact us at mach15@china.harvard.edu.